Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the questions related to the vector space. Myself Dr. Harish, you can follow my YouTube channel where you can find the playlist of the CSIR UGC net and you can see the various lecture on the entire function, countability, rank, eigenvalue, all are available in this playlist. The objective of this lecture is we will discuss the 50 plus question in this lecture related to the part B and part C on the topic vectors space. I hope you can subscribe my YouTube channel so that you can get the notification when I upload my next video. Now the first concept that comes in mind when you're talking about the vector space is subspace. What is the meaning of that is if you have any subset W of the vector space V, if you choose any of the two elements U and V from that vector space, then the linear combinations of this vectors must belongs to that element W. If this property holds, then you can say it is my subspace. Another way, if you have a subset, then take the two elements, then their addition is also the part of this, and scalar multiplication is also belongs to this. And the most important thing is 0 must belongs to the elements W. 0 element must belongs to the, that's why it is a non-empty subset. But the question arises is how you can check about whether it's a subspace or not. If you want to prove that it's a subspace or not, then you have to satisfy all these three properties. Or you can easily prove that alpha u plus beta v is a part of W. If you want to disprove that is a not a subspace, you have to provide one counter example which is not satisfied. Make sure student, if you want to prove that W is a subspace, if you want to do it graphically, then any of these straight line which passes through the origin, any of the straight line which passing through the origin is a subspace. However, any of the line which not passing on the origin is not a subspace. Fine. This is the step number one. Based on this, you can discard many options directly. Second is if you have a non-linear subset, if you have any of the non-linear subset, then it implies it is my not subspace. For example, if I consider the collection of all those elements of the xy such that x square is equal to y, clearly say x square is my non-linear, fine, so this is not a subspace. Similarly, if I consider x comma y is the say x plus sine x is equal to 0, then again you can see the sin x is my non-linear, it is not a subspace. So based on this step 1 and step 2, I can solve many problems in a very simple manner. If you are new to my YouTube video, you can scan and join my WhatsApp group. I hope you can like and comment on my this video. Which of the following are my subspace? You can see, you can draw it graphically. X plus y is equal to 0. Which passing through the origin? Yes, it's a subspace. Second one, x minus y is equal to 0. It passing through the origin? Yes, it's a subspace. Third one, x plus y is equal to 1. It is not passing through the origin. Is it passing? No, it is not a subspace. X minus y is equal to 1. This is the line of the x minus y. Again, it not passing through the origin. So this is also not satisfied. So the right answers are A and B are my correct options. Which of the following set of the functions are my vector space? Again, your target is similar. S1, S2 and S3 clearly say 0 does not satisfy. If I choose Gx is my 0, then 0 is equal to 1 not satisfied. So S2 is not a subspace. Fine. All are subspace wrong. Look at the first one, 0 satisfied. Then if I choose any of the two functions from the S1, that means the limit of the f is my 0, limit of the g is my 0. Then our target is to find what is the limit of this case. If it is also 0, then it is a subspace. So clearly say if I take the limit as x approaches 3, limit of this is 0, limit of this is 0, so this will goes to the 0. So yes, this is my subspace. Third part is if I choose any of the two functions f and g such that it belongs to my S3. That means limit of the f exists. I call as L1. Limit of the g is my L2. Both are my exist. That means it is my finite. Fine. Then what is the limit of this case? Again, it is a finite because if you take the limit on the both sides, this is my L1, this is my L2. So the limit is my, which is my finite. So once this is my finite, yes, it is my vector space. So that means only S1 is cancelled. Right option is C is the correct option. Mn is the vector. Firstly, I can choose n is my 2. Fine. Which of the following are my linear subspace? I can choose any matrix A, B, C, D. Fine. What is the V2? AD minus BC is equal to 0. Clearly say this is my nonlinear. Why is the nonlinear? Because of the AD, because all are my unknowns. So AD is my nonlinear, so it is not a subspace. What is the trace of the A? A plus D is equal to 0. It is linear. If you draw the graph, yes, it passes through the origin. Yes, it's a subspace. A is my non-singular. How you can prove the non-singular? But if I choose A is my 0, fine, then it is my, is it a non-singular? No, it's a singular matrix. So this is not the subspace because 0 does not belong to the V1. B is my some fixed matrix. B is my fixed matrix. I can choose B is my identity. Fine. Then your vector, this will be my A such that A belongs to the Mn. Then clearly say 0 is the part of the Mn. If you choose any two elements of the Mn, A plus B is also the Mn. Alpha times of the A is also the part of the Mn. Yes, this is my subspace. So the right answers are C and D are my right answers. If you are unable to understand about the graphically like linear, nonlinear, you can also solve the same problem like determinant is 0. You can choose any example. This is the determinant 0. Another one is, this is also 0. This is the part of the V2. This is the part of the V2. Does the A plus B also the part of the V2? No, because what is the A plus B? A plus B is this case and determinant is my non-zero. So that means this property is not. M is my vector space of the 3 cross 3. A is my any matrix. Clearly say this is again my fixed matrix. Fine. What is the meaning of the fixed matrix is? That's any of the constant number. Then does x of A is my non-linear? No, because A is my fixed matrix. Once is a fixed matrix, that means a constant number. So I can see like say 3x or 4x. That's a constant. So that means this is my linear. Fine. Once is a linear also, it passes to the origin because 0 satisfied. Yes, this is a subspace. A is my fixed matrix. That's a constant matrix. Again, it passes to the origin. Yes, it's a linear. And passing to the origin. Yes, it's satisfied. Trace of the AX. Whatever the matrix A, trace of the AX. Trace means the diagonal sum. That is always be the linear. And it is given as a 0. That means trace x11 plus x12 or x22 plus x33 is my 0. Is a graph of this. It's a plane which passing through the origin. Yes, it is my subspace. Determinant is always been a non-linear. Fine, because if you taken as a x, what is the determinant of the x is a non-linear factor, and every non-linear is not a subspace. Dimension, okay, it's n is my 2. So if I choose n is my 2, then it's a 2 cross 2. Okay, remember student, whenever you have to find the dimension of the any matrix, you have to think about this method. All those symmetric matrices. real entries, trace is my 0. What does it mean? If this is my A, this number is my minus A. So there is no need to compute this number. If it is symmetric, this is my B, this number is also B, so there is no need. Then how many unknown vectors, how many unknown elements are there? 2, that is my dimension. So now look at that, n is equal to 2. So this is 4 minus 2 over, so it will be 2 minus 1 minus 1, 0. So, but we need a 2. That option is cancelled. 4, 2 minus 1, 6, 3 minus 1, 2, satisfied. 4 minus 4 minus 1, which is minus 1. Cancel out. 4 plus 4 minus 1, which is 3, which is not equal to 2. This option is cancelled. B is my correct answer. Always think about this manner. You can get your answer within the 10 to 15 seconds. I hope you can like and comment on my this video. I will upload the next video only based on your likes and comments. If I got a good response on the like and comments, I will upload the video very soon. Let W is the polynomial with the real coefficients where the matrix V is my this. Then the dimension of this matrix. I think very simple. Dimension, that means you have to find the rank. What does it mean? This is my companion matrix. I think all of you know that the diagonal entries are my 0, upper values are my 1. So what is the characteristics equation? It's a 3 cross 3 minus 0 lambda square, because the diagonal elements are in the upside. I can start from this minus 0 into lambda minus 1. So that means lambda cube is my, so that means the equation, characteristics equation will satisfy this condition. What does it mean? That means this is a condition imposed on the matrix B. Fine. Now, what is the polynomial? What kind of the polynomial of this? It will be identity plus some constant, say a1 of b plus a2 of b square plus a3 b cube. But b cube is identity, so this element. How many constants are there? This is a naught. How many constants are there? 3. So dimension is my 3. This 3 does not satisfy. 3 does not satisfy. Equality hold. Equality hold. C and D are my right answers. Let n is my positive integers. Hn is the space of all n cross n matrix. I can choose n is my 2, such that Aij is Ars with I plus j is R plus S. Fine. First one is A11. This number is A. A12 and A21 are same because 1 plus 2 and 2 plus 1 same. It is a B. This is also B. There is no need to write. Then A22. This is my C. How many unknown elements? 3. Now look at the option. When n is 2, answer is 3. Wrong. When n is 2, answer is 3. Fine. When n is 2, this is 5. When n is 2, this is 3. Now 2 answers are correct. Fine. Now we can change the number of the n. Let n is my 3. Then it is my 3 cross 3. First element is A. Then it is my A12. Sum will be 3. This number, this number. What is the A? Next element is A13. That is sum is my 4. The diagonal entry is also C. This is also C. This number is my A23. Sum is my 5. So this number and this number are same. And the last number is my, what is the dimension of this case? Is my 5. So when you take n is equal to 3, 6 minus 1, 5. When n is 3, 9 minus 3 plus 1, which is not equal to 5. So this option is cancelled. Only D option is my right answer of this problem. Always choose about a particular value of the n. Think about this manner, you can get your answer very soon. I hope you can like and comment on this my video to support myself. Let's see is my n cross n real matrix. V is the vector space spanned by this. So I can choose n is my 2. What is my W? I, C, C square, C cube, C4. Fine. Then the dimension of the vector space V. Remember, firstly check whether any condition on the matrix C is given to you. Any condition on the matrix is given to you, like this, like which matrix B, like this matrix. This is the matrix and there is some condition imposed on that. Is that case also applicable in this one? Is there any condition imposed on this? No. Then if there is no condition imposed on this, then the dimension of this will be my minimal polynomial of this set. Now clearly say all these elements are generated from this matrix C. Fine. So what is that? Only one. So dimension is my 1. So at most n is by 2 is by 4. At dimension is 4. Dimension is 4. Dimension is at most 4. Dimension is at most 1 is the right answer of this. Remember always when some condition imposed on that, then you have to write up to that case. But since there is no condition imposed, then you have to find the minimal polynomial. Again, the dimension of this matrix, I can choose n is by 2. It is my 2 cross 2. All those real and symmetric matrix. Entry A11 is my 0. Trace is also 0. This cell is also my 0. And it is my symmetric. If this number is A, this number is automatically A. What is that dimension? How many unknown elements are there? Only one. So now you can check about that. When n is equal to 2, is it 1? It is not 1. It is 4 minus 2 plus 4 divided by 2. So 6 by 2, 3, which is not 1. It is 4 plus 2 minus 1 over 2. It is not 1. Then this one is 4 plus 2 minus 2 over 2, which is 1. So A is my right answer. And you can see within the 10 second, you can get your answer in a simple method. Let n is the positive integer which is greater than or equal to 2. I can assume n is by 2. Mn is my M2 is the matrix of the 2 cross 2. B is my 2 cross 2 orthogonal matrix. What is the meaning of the orthogonal matrix? B into B transpose is identity. Fine. Then consider the WB, which is defined like this manner. I can substitute the value of the B transpose, which I can written as a B inverse A of B, such that A is the part of M2R. Fine. Now, what is the meaning of that? B is my invertible matrix. WB is the collection of all those this manner. So, how you can write that? This number I can say WB is similar to the matrix A. Once this is similar, that means the dimension of the WB is dimension of A is the elements of the M2. So is this. Once the both have the same dimension, so that means W2 is same as M2. Because I have considered n is equal to 2, third option is the correct answer. Now, whether it's a subspace or not, so clearly say WB is the element of the A. A is the part of the, and A, if A and B, I consider two elements of the M2, then definitely A plus B is also the elements of the M2. Fine. 0 also belongs to the M2 and alpha of A is also belongs to the M2. So yes, this is my subspace. So fourth option cancel. Now look at that. What is the dimension of WB? Dimension of the WB is same as of the M2. So that means dimension is my 4. What is the rank of the B? Because B is orthogonal matrix. So that means determinant of B is my non-zero. So what is the rank of this matrix? Rank of this matrix is by number of this column vectors. So 4 is less than equal to 2, not specified. Dimension, rank of the 2. What is the rank of the B transpose? Rank of the B transpose is always same as rank of the B, which comes to be n. Let P is the span of x1, x, x square, x cube, and so on. Fine. So that means like span means that is a linear combination of these elements. Okay, fine. Then P is a vector space. We are not talking about the subspace. P is a vector space of all real valued continuous function. If I choose the function is my sin x, is it belongs to the P? No, but it's a continuous function. Fine. It's the continuous function, but does not belong to the P. So this option is cancelled. P is the subspace of all real valued continuous function. Is it a subspace? Yes. Why? Because it form a subspace. Yes, because if you choose any of the two, it's a polynomial. First of all, it's a polynomial, and P of n is always form a subspace. Moreover, span is always form a subspace. Span, the span is a subspace. So this option is the correct option. Pi is my Li. How you can prove the Li? If I multiply with the alpha i's plus alpha 2 x square, alpha 3 x cube, then what does it mean? Each of the alpha I is my 0 by equating the coefficient. So yes, this is my Li. Trigonometric functions. So let's say trigonometric function is say my cos x belongs to the P, but P is the span of all those elements only, polynomials. That is not belongs. This option is cancelled. Correct options are B and C are the right answers. Let Pn is a polynomial vector space of all those real polynomial of degree at most n. I can choose n is my 2. Then this are the inner product cases 1 because n is my 2, then it is x square over 2 factorial. 2 factorial is my 2. Then it are the orthonormal bases. What is the meaning of the orthonormal basis? That is each element with itself is my 1 and otherwise 0. X square by 2, x square by 2 is my 1, otherwise 0. Then define the value of the f alpha summation I varies from 1, 0 to 2, alpha 0, alpha 1x, alpha 2, x square. G is my beta 0, beta 1x, beta 2x square. Then your target is to find the inner product of the alpha f and g. Very simple. If you do the inner product, this is the constant. 1 into 1, sorry, it's 1 into 1 is 1. It's orthonormal. Fine. So alpha 0 into alpha 0 is 1 plus alpha 0 into beta 1x. But what is the orthonormal? 1 into x is 0. Fine. Similarly, alpha naught into x square is 0. That means you have to taken this side. Fine. But remember, this is x square over 2. So what I can do is I can multiply by 2 divided by 2 multiply by 2 divided by 2. So that means inner product of this is 1. So this number is my 4 times alpha to beta. Now look at the option. If I open this bracket, I varies from 0 to 2. 0 factorial 1 plus when I is equal to 1, it's a 1 alpha 1 beta 1 satisfied. When n is equal to I is equal to 2, 2 factorial is my 2, but we need a 4. Both options are cancelled. Now check whether these are satisfied. I is equal to 0 satisfied. I is equal to 1, 1 square is 1. I is equal to 2, 2 factorial, 2 square, that is 4 alpha 2 beta 2. Yes, it's satisfied. Because it's an orthonormal basis, so by the Gram-Smith process, we can get a unique transformation. So D is my right answer. There is another such transformation does not exist by the Gram-Smith process. Xi is the primitive fifth root of unity. Xi raised to power 5 is my 1. Matrix A, clearly say this is my diagonal matrix. Fine. eigenvalues are my diagonal entries. These are my eigenvalues. Fine. V is defined as V A V transpose. Then your target is to find this one. Very simple, very simple. Because first of all, you can see this bracket is my quadratic form. Fine. Now A is my scalar, or you can say A is my diagonal matrix only. Fine. Then there is no need to write this is my V or this is my W. Then you will write as a W, then the matrix A, then the transpose, and then multiply and then square root. There is no need. What is the simplest shortcut to access? Because it's a diagonal matrix. Fine. That's just like a scalar. What you can do is WA square root V into V transpose. That means your target is to find WA into W transpose. Fine. Now simply you can do W into W transpose. That means 1 A first eigenvalue. What is the transpose of this number? 1 plus second minus 1 second eigenvalue second plus third eigenvalue into this plus 1 xi 1, and the last one is minus 1 xi square into minus 1. So what is the right answer of this? So clearly say this is my xi of minus 2, xi of minus 1, 1 xi square. What is this number? This is the sum of the roots. So what is the sum of the roots? 0. So right answer is 0. Moreover, you can write as a xi is xi cube, xi minus 1 is xi raised power 4. So you can see this is the sum of the roots of this unity, that is a 0. So 0 is my right. Xi is the cube root of unity. Again, you can see this is my diagonal matrix. Fine. And this is my quadratic form. Fine. So then W is given to you, or you can find the value of WA. I can choose this number and the first eigenvalue. 1 into 1 is 1 into the first value plus 1 into 1 into first value of under. What is given to you? This is my 0. Or you can see xi inverse. Xi inverse I can write as xi square plus 1 plus xi, which is 0. That's the sum of the root, because it's the sum of the root of this unity is 0. V1 and V2 are the subspace of the vector space. Which of the following is necessary a subspace? We all know intersection is always a subspace. Union need not be the subspace. Fine. So first option is correct. Second is cancelled. Sum is always with the subspace. This one 0 does not belong to this part. Fine. If I take it as a 0 comma 0, so clearly say the second element does not belong to this. It is not the subspace. So the right answer is only right answers are A and C are the correct. Let n be the positive integer. I can choose n is by 3. Ui's are my linearly independent, and u0 given to be this. Firstly, v1, v2, w1 are li for this. You can see this is a very large number. Fine, but you can think about that. There is no role of this. I will tell you. First, you can find the value of v1. v1 will be u1, u2. v2 will be u2, u3. v3 will be u3 plus u4. What is the u4? Because I taken n is 3 is u1. Fine. I have taken n is my 3, which is odd number. Or if you choose n is 4, that is my even number, and that's the same thing they are talking about. That this is even number, this is my odd number. Now you can prove the li. I can start with the alpha into vi is 0. Fine. If I take into alpha into ui, and ui's are my li. So like alpha 1 plus alpha 3 of u1, alpha 1 plus alpha 2 of u2, and alpha 2 and alpha 3 of u3 is my 0. Fine. Now since ui's are my li, that means the coefficients are my 0. Alpha 2, alpha 3, alpha 1, alpha. So from clearly say from this case, each of the alpha I are my 0. That means this is my li. Then n is my odd. Fine. Now, what will happen if n is my even? What will happen if n is my even? Then in that case, v4 is my u4 plus u1. Then again, I can start from the alpha I of vi is equal to 0. That means the coefficient of alpha 1 plus alpha 4 is 0. Alpha 2 plus alpha 1 is 0. Alpha 2 plus alpha 3 is 0. And alpha 4 plus alpha 3 0. Now if you add them, what you conclude, alpha 1, alpha 2, alpha 3, alpha 4 is my 0. But you can see from this case, alpha 1 is minus alpha 2, alpha 1 is minus alpha 4 from this. That means alpha 2 and alpha 4 are same. But from this case, alpha 3 is my minus alpha 4, alpha 2 is my minus alpha 3. So all elements are the part of the alpha 4. That means they are my LD. So therefore, whenever n is even, this is my LD. Look about the second case for the W. How you can define for the W? Firstly, I can take n is 3. Again, they are the even and odd cases. What is the U1? U0. U0 is my 0 plus U1. This is U1, U2. W3 is U2, U3. Fine. So clearly say this is the Li because if you write the matrix corresponding to the U1, this is the U2, and this is U3. So clearly say the determinant is my, if I call this matrix is A, determinant is my non-zero, that is it is Li. So whenever n is even, it is my Li. If I write corresponding to the W4, what will happen for the W4? W4 will be U3, U4. If I write the matrix 1 1 0 0, 0 1 1 0, W 0 0 1 1 and 0 0 0 1. Again, clearly say what is the determinant of this? 1 is a diagonal entries which is non-zero, it is Li. Therefore, whether n is even or odd, they are Li. So the right answers are B, C, D are the correct answers. Let V is the vector space. You can choose any, say V is equal to R. Field is also you can choose n as R. And E1, E2, E3. I can choose n is my 1. So your basis is my E1 only. C will be, because n is 1, so it's x1 only, x1 E1. Then C is Li implies xi's are non-zero. Okay, firstly think about this. Xi is my non-zero. Your target, check whether C is Li or not. Because there is n is 1, so I can start with this. Start with let alpha x. This is my 0. Fine. Now, because x1 is my non-zero, E1 is my basis, which is my non-zero. What does it implies? Alpha is my 0. Therefore, it is my Li. So C is my Li. This option is correct. Look at the first one. C is given to be Li. Fine. This implies Xi are my non-zero. Assume that if X1 is my 0, what does it mean? C is my phi, that is my LD, but C is given to be Li, singleton set. So that means this is my contradiction. Therefore, Xi is my always Look at the third option. The linear span of C is my V. What is my C? C is my x1, E1. This is a span, fine. Also, this set is C is my Li, fine. Also, we prove that C is my Li. If C is my Li, what does it mean? Xi is my non-zero. So that means it is my true. Because span and Li, this means these are my bases. That means again by the first part, it's a correct statement. D option. Xi's are my non-zero. Fine. That means the linear span of the C is my V. It's a span. It's a Li. It's a basis. Fine. Dimension of the C is my 1, which is same of this n. Yes, it is my same. So all are my correct answer of this problem. You can solve this problem by taking n is equal to 2 as well. Kindly like and comment on my this video. For an arbitrary subspace U, V and W of this. Now, clearly seen from the first and second, either one of them is the correct option because one is a subset and second is a superset. Similarly from this. What is the subspace? As I gave you the shortcut with is a line which passing through the horizon. So I can consider graphically. Let's say one subspace is my this which passes through the horizon. I call this is my U. Fine. V is my subspace which passing through this horizon, that is my V, and this is my W. What is the meaning of that? V is collection of all those points on the x-axis. Fine. W is the point on the y-axis, and U is the collection of all those points of x comma x which passes on this horizon. Then first point is I need to find V plus W. Is a V plus W is plus collection first element, so that is the part of the R2. Then what is the intersection with respect to V? What intersection with respect to U? So R2 is my complete. What is the intersection with respect to U? It's my U. Fine. So left hand side is my U. What is the intersection of V and U? V and U intersection is only this point 0 comma 0. What is the intersection of U and W? U and W is again 0 comma 0. Then what is the addition of this? 0 plus 0 is 0. Fine. So that means this value is my U. Is this condition hold? No, because U is the complete line. U is not the subset of this. This is my U. Is U is the part of yes. What does it mean? 0 comma 0 is the subset, is the proper sub. Yes, that's the correct state. Now look at the third option, third and fourth. What is the U intersection V? U intersection V, sorry, U intersection V only 0 comma 0. If I add them W, what is that? W is my this 0 comma 0, that's itself complete W. Fine. The left hand side is my W. What is the U plus W? U plus W are 2. V plus W. All those elements are 2. What is the intersection of this portion? R2. Now you can see W is the part of the R2. So W is the subset of the R2. So C is the right answer. B is my right answer of this problem. Or you instead of the R2 you can see W plus V is a collection of all those elements plus whose first component is my 0. V because it's a plus sign. So all those elements of the first axis and this second component. V is my three-dimensional vector space. Okay. If you read this statement, firstly I will give the tips. The number of distinct k-dimensional subspace. I will give you the general formula and then I will tell you how you can solve it. So firstly, I can write the formula p raised to power n minus 1, p raised to power n minus 2, p raised to power n minus p square up to p raised to power n minus p raised to power k minus 1. I will tell you what is the p, n and k divided by p raised to power k minus 1, p raised to power k minus p raised to power k minus p square and up to p raised to power k minus 1. Now, what is the n? What is the n? N is my dimension of the vector space. Fine. What is the p? P is the dimension of field and k is my kth dimension. This is my k. Now, if you look about this example, what is my k? K is my 1. What is the n is vector space? Which one is the vector space? This is my vector space. What is the dimension is 3. What is the field? This is my field. How many elements? 3. K is my 3. Now substitute all these values in this case. Whenever n k is my 1, so 1 minus 1 0, p raised to power 0 1, that is only the first term. 3 raised to power 3 minus 1. Again, only first term. P is my 3, k is my 1. So that means 27 minus 1, 3 minus 1. 13 is the right answer of this. F is the finite field of order Q, is the number of the two-dimensional subspace. Again, the same formula you can return. You have to identify what is the K, what is the N, what is the P. K, two-dimensional. What is the N is? Vector space. What is the vector space is? This is my vector space. What is the dimension of the F3? 3. What is the P? Field. It's a finite field. Order is Q. This is my Q. Now once it's a K is equal to 2, you can see it's a 2 minus 1. That is the first two terms. So your formula will be P raised to power n minus 1, P raised to power n minus P divided by P raised to power K minus 1, P raised to power K minus P. Now you can substitute the value. P is my Q, Q cube minus 1, Q cube minus Q divided by Q square minus 1 and Q square minus Q. So clearly say this term and this term will be cancelled out. 1 Q is left. Q cube minus 1. I can take an Q as a common. Q minus 1. Again you can see I can divide them. It's a Q square plus Q plus 1 is the right. This is the same form. Fine. Q cube is the cancel. C is my right answer. Consider the following row rank, the dimension of this vector space. So basically, you have to convert into the row reduce echelon form, or you can simply find the rank of this matrix. If I write this matrix 1 1 0 0 0, second element is 1 1 0 0 1 0, 1 1 0 0 0 1, 1 0 1 1 0 0, this 1 0 1 0 0 1. So your target is to find the rank of this matrix. Now clearly say if I subtract them 0 0, this number will be my minus 1. Similarly, I can subtract this minus this 0 0 0, this number will be my minus 1, rest elements are. Again our this number is 0, this number will be my minus 1, this is 0 0 and so on. This is my 0, this number is my minus 1 0, this number is again my minus 1, rest are same. And similarly for the last case, this is 0, this number will be my minus 1, this number is my minus 1. Fine. Now clearly say if I subtract them, this will be 0, this will be 0, this will be 0, and this number will be my minus 1. Clearly, if I subtract these two elements, this is 0, this number will be my minus 1, and clearly say the third row and the sixth row are same, so this value will be complete 0. So definitely the rank will be less than 6. 6 will not be the answer. Similarly, you can subtract them. This number will be 0, this will be 0, and find. Now you can see the second row, fourth row are same. If I subtract them, this matrix is also 0. So the rank will be less than of 5. Fine. Now, if I add them, there is no need. This is here. So clearly say the rank of this matrix is the remaining L. V is my A is my M of 10 is the vector space of 10 cross 10 matrix. WA is my subspace. It is given to you as a subspace, which is spanned by A raised to power n, where n is my greater than equal to 0. Fine. So it is a collection of M10. It's a 10 cross 10. So what is the A raised to power 0 I? It's A square, and so on. Fine. These are similar of the previous one, which I have explained you, C square of this. Is there any additional condition imposed on the A? You can see there is no condition imposed on the A. So that means the dimension of this WA, what will be that? The minimal polynomial of the A. Fine. So what is the minimal polynomial of this? It's a subspace of the dimension 10. So that means that dimension will be under this restriction of the A, that is of 10. So the dimension of WA is less than equal to 10. A is the correct option. Strictly less than, strictly is the 100 is the wrong. Because the minimal polynomial, how many, what is the n is 0 to 100. So what is that maximum is 10, because the subspace of the M 10. Which of the following has the same row space? What is the meaning of the same row space is? Rank will be the same. So anyhow, I will convert into the row reduced echelon form, and we will see which one is equivalent. 1 2 1 3 6 1. I can also divide this by 2. Fine. I can multiply by 3 and subtract 0 0 minus 2, and I can subtract this number 0 0 minus 1. Based on this, I can make them as a 0 based on this number, and I can divide it this by minus of 2, it will be 1. I can use R1 minus R2, I can make this as a 0. Now this is my row reduced echelon form. So you can see the first option is the right, because the rank of this matrix will be 2. This is also 2, this is also 2, this is also 2, but it is equivalent to this. Let V is the span of 111, V is the span of this. That's a linear combination of this number. Let U1, U2 and U3 are given to this number. Which of the following is connected, not connected, and so on. I think it's a very simple, because once it's connected, you can think about the subspace. That means you have to find the, okay, how you can think about that. V is a subspace. V is the span of this. What is the role of the U1, U2, U3? Okay, these are the elements of the U1, U2, U3. Okay, R3. Okay, firstly, clearly say the set U1, U2, and U3. Firstly, we will check whether it's Li or Ld. Fine. I can start with the matrix 1 1 0 1 0 1. Clearly say that determinant is my non-zero. Determinant will be 1 minus 1. It's a non-zero. That means ui's are my Li. Fine. Then R cube minus V. What is the V? Is the span of this element. Okay. R cube minus V. It is not connected. Okay. First option. R cube minus V union 0, 0, 0 is not connected. Now it is a connected. Is first okay. Is it a subspace? 0 belongs R cube minus of this element. Yes, this is my subspace. So once this is a subspace, that's a path connected. So you can say this is a path connected. Fine. Once the path connected, yes, it's a path is a connected, but he said not connected. This option is cancelled. R cube minus of this is a connected set. So that means U1 and U3. U1 and U3 minus V. Is the U1 and U3? U1 and U3. Can you write this element in terms of U1 and U3? Firstly, we can check whether U1 belongs to the V or not. Can you write, can you choose alpha and beta such that you can make as a U1? No. So U1 does not belong to the V. Can you make as a 1 that second element will be 0, but it is not possible to make them as a 0. So that means this element does not belong to the V. So once U1 and U3 does not belong to the V, what does it mean? This element does not belong to the V. So for this case, 0 does not belong to this set. That means it is not subspace. That means it is my not connected. But is that connected? Look at the third case. Let me clear this one. Third case is U1 and U2. Can you make 0, 0, 1, 1, 0? Or you can make clearly say this number 1, 1, 1. You can write this as the element of U1 plus U2. Fine. So if you, yes, this is the 111 is a part of U1 plus U2. That means, what does it mean? This, that is the CLC of convex, not a convex linear combination. That's a linear combination of U1 and U2. If you take the union with respect to R cube minus V, find this as a path connected. Once this has a path connected, it's a subspace. So yes, it's a path connected. Is this also the part of this connected? 1, 2, 2. Yes, it's because 0 is also the part of this for all the real numbers. Okay, it's a subspace. If it is a subspace, yes, it's a connected set. Yes, this is also the right answer. C and D are my correct answers. So basically, you have to think about the whether it's a subspace or not. Px is a non-constant polynomial of degree n is greater than 1. Basically, your Px will be a0, a1, x. Now you can see the options are not depending on the a0, a1. I can choose a0 is 1, a1 is 1. Fine. Then q is my integration of p. What is the integration of p is x plus x square by 2. R is my derivative of this p. R is my 1, q is my this number. Then first option, q and r. Q, that is x plus x square over 2, and r. R is my 1. They are li or not. Clearly say it's li or not. You can see if I multiply the first number by alpha 1 plus alpha 2 of 1, then my target should check what is the alpha 1, alpha 2. Equating the coefficient, alpha 1 is 0, alpha 2 is 0. Yes, they are li. So first option is correct. Q and R are LD test. X raised power n is by 1. So x raised power 1 belongs to the span of Q and R. How you can check about that? I can write this is alpha 1 of span of Q and R. If you equate the coefficient x alpha 1, x square 0 and constant 0. So clearly say from these two cases that is contradiction. So that means x does not belong to this case. X of n plus 1, that means x square belongs to the span of Q and R. X plus x square by 2 plus alpha 2 of 1. You can equate the coefficient x square 1 alpha 1 over 2 constant alpha 2 coefficient of the x 0 alpha 1. Again you can see from one side alpha 1 is 0, from this case alpha 1 is 2, which is not possible. So the right answer is only A is my correct answer. And you can see I have converted the very complex problem to the very simple one, and you can solve it in a fraction of a second. Don't forget to like and comment on my video. A is by 5 cross 4 a real matrix such that the space of all the solution is given by solution is 1 plus 2s, 2 plus 3s, 3 plus 4s, 4 plus 5s. Then the rank of this matrix. Very simple. How many unknown elements in this solution? How many unknown elements? One, and that unknown element is my nullity. Because there is only one unknown element, that's a S. So that unknown element is my nullity. Once you know the rank, how you can find the rank? Rank plus nullity is my number of the column vector. Column vector is my 4. Nullity is my 1. Rank will be 3 is the right answer. You can find the same, because this is related to the rank, you can find the same question in my rank video. Which of the following set is my basis? Basis means you have to prove the Li, you have to check the span. Now, what is the dimension of this? 1, 2, 3, 4. So, dimension of the S1, dimension of the B1 is same as dimension of the R4. So, now for the basis, you have to check only for the Li. Fine. Similarly, for the B2, dimension are same. Again, you need to check only Li. Again, to check only L. So, let's start with the B1. There is no need to check for the B1. In each option, they are talking about the B1 is already there. Now for the B2, how you can check about the Li? I can write the matrix, find the determinant, or find the rank. If rank is my 4, then you can say this is my Li. What is the determinant of the B2? Clearly say this is my diagonal entries. Fine. So determinant is my non-zero. So if it is non-zero, that means it is a Li. So yes, B1 and B2. Only B1 is the wrong option. Similarly, I can define the matrix B3. B3 is my 1, 2, 0, 0, 0, 0, 1, 1, 2, 1, 0, 0, -5, -5, 0, 0. Can you find the determinant of this? It quite be difficult, but I can change into the row reduce. So I can multiply by 2 and minus. This 3 will be my minus of this. Fine. Then this number will be my 0. If I multiply by 5 and add them, 10 plus 5, 15. Fine. Now I can multiply this 5 and then add them. Then this number will be my 0. So clearly say the rank of this matrix is less than of the number of the column matrix. So it means this is my not Li. B3 is not the Li. B1 and B2 but not B3 is the right answer of this problem. Let V1, V2 are the elements of the R4. So you can choose any of the elements. Fine. V2 I can take as a E2. W1 I can take as a D3, E3. W2 I can take as a E4. Such that this is my basis. We will firstly check whether it's basis or not. V1. This is my V1. V2. Fine. V1 plus W1. 1010. V2 plus W2. 1 1. So clearly say determinant is my 1, which is non-zero. So yes, these elements satisfy. Fine. Then which of the following statements are the basis? Again, it's R4, 1, 2, 3, 4. So we need to check only about the Li. How you can find the Li? I can write the matrix V1, V2, twice of the V1, thrice of the V2, twice, thrice, 5 times V2, 3 times this. Now, what you can do, can you find the rank, or I can convert them, I can multiply the 2 and 0. Fine. I can multiply by 5 and subtract them, 0. Fine. Then clearly say what is the rank of this matrix. It is 4, and rank of the 4 is same of this. So yes, it's a Li. So this option is the correct option. Look at this next option. V1, V2, twice of V1, twice of W1, V1 and W2. Now clearly it's a diagonal matrix. That determinant is a non-zero. So this is the L. Third option, V1 plus V2, 1 1 0 0. V2, V1, W1, twice of V1, 5 times, minus 4 0. If I multiply by 2 and subtract them, this comes to be 0. Multiply by 2, subtract them, it is my 3. Fine. Then I can multiply 3, subtract them, this is my 0. I can multiply this by 4 and add them, this will be 0. So clearly say the rank of this matrix is less than 4, that means it is my not L. Similarly, we can check about the last option, V1 plus V2, V2, W1, W2, and twice 1 1 1. Now I can multiply 2 and subtract them, this is minus 1. I can add them, it will be 0. Now clearly say these two rows are same, so the rank of this matrix is less than of 4, so it is not L. This option is also cancelled. A and B are my right answer. AIs and BIs are these. I can choose L is my 2. Fine. So these are the R2. P is my 2 cross 2 matrix such that P of AI is BI. P is my 2 cross 2 matrix. Suppose every eigenvalue of the P are my minus 1 or 1, then Q is my this, which are the following. So every eigenvalue of Q. Can you find the eigenvalue of Q? 1 plus twice the eigenvalue of the P. So that means it will be either 3 or minus 1. So eigenvalue of 3 or minus 1. Product of the eigenvalues is my determinant of this matrix. This is my product of the eigenvalues. What is the product of the eigenvalue of the Q? Is my minus 3, which is non-zero. That means Q is invertible. Fine. If determinant of P is my greater than 0, clearly say that because I have the 2 cross 2 matrix, so eigenvalues are 1 and minus 1. Determinant of P is my minus 1. But if the determinant is my greater than 0, then determinant of Q is also greater than 0. It means if eigenvalues are either minus 1 or 1, That means P has eigenvalue 1. What is the eigenvalues of the Q? When P has eigenvalue 1, eigenvalue of Q is 0, 3. P, determinant of P is my greater than 0, determinant of Q greater than 0. Now, A plus AIs plus 2 is also the basis of the V. Okay, since AIs and BI are my basis, fine. A plus BIs. Q is my invertible, as I proved that. Sorry, Q is invertible because determinant of Q is my non-zero. So Q is invertible. Q is invertible. What does it mean? Q maps Li's set to the Li. Fine. So that means what is the Q of AI? It's AI plus twice of this, but P of AI is my BI. So yes, this AIs and BIs are the basis. So this is also the basis. All are my correct answer of this problem. V is the vector space of the polynomial f of x comma y. Degree is less than 3. Always remember, whenever there is a transformation, you always need a degree less than or equal to. So I can write as a 2. Can you write the standard basis up to the degree 2? 1 x y x square x y square. These are my basis. Then you can define the derivative of this. Now that's it's a very simple. I can write as a 1 x y x square x y square. Take the first element. Partial derivative with respect to x 0. 0 is a constant. So first element will be 3 6. X partial derivative is a 1. So linear transformation is 1. Rest elements are 0. Y. What is the partial derivative? 0. 0 is my constant. This part. X square partial derivative is my 2x. The coefficient of x is my 2. Rest values are my 0. Xy partial derivative of this is y. Coefficient of y is my 1. Rest values are my 0. Y square partial derivative with respect to x is 0. So all values are my 0. Then the nullity rank T is invertible. Clearly say the last 3 rows are my 0. So that means the rank of this matrix A is my 3. How you can find the nullity? The number of the columns are my 6 minus 3 is my 3. The nullity is at least 3. Equality is there? Yes. The rank is at least 4, but rank is 3. 3 is not greater than 4. Rank is at least 3. Yes, equality is satisfied. T is invertible, not possible because the rank of the matrix is not equal to number of the column. So right answers are A and C are the correct options. W is the space of the linear combinations of this. Firstly, I can write the linear combination alpha 1 sin z, alpha 2 cos z, alpha 3 sin of 2z, alpha 4 cos of 2z. T is a transformation which is by the complex derivative. So T is defined as f dash. Then which of the following statements are my two dimension? We will check about the Li. Fine. It is for the all z. Firstly, I can take z is 0. So that means I can start from this Li. Fine. If z is equal to 0, 0, alpha 2, alpha 4, 0. Take any other number, say z is pi, sine 0. This is minus 0 plus. So clearly say from these two cases, alpha 2, alpha 4 is my 0. Now I can take pi by 2, sine pi by 2 is 1, 0, alpha 3, sine pi 0. So So that means alpha 1 is also 0. I can take z is 3 pi by 2 or any other number. You will get alpha 4 is 0. That means this set, the set W is my Li. Once this is my Li, what is my dimension? There are the 4 elements, dimension is 4. Now, second part, span Jordan block. So firstly, we can find the Jordan block. For that, we need to write the matrix. It is my sine, it is my cos, it is my sine of 2z, and it is cos of 2z. Now, firstly, sine z. What is the derivative of the sine z? Is cos z. So, coefficient of the cos is 1, rest are 0. Second element is cos. Derivative is minus sine. So, derivative coefficient of the sine minus 1, rest 0. Derivative of the sine is 2 cos 2z. So 2, rest values are 0. Cos will be minus of 2, rest values are 0. This is my matrix A. Now, how you can define the blocks? Now clearly say how you, for the block you need to find the eigenvalues. So these are my 0. What is the eigenvalue of this block? Plus minus of this number, that is plus minus iota. What is the eigenvalues of this? Plus minus 2 iota. So the eigenvalues of this matrix is iota, minus iota, 2 iota, minus of 2 iota. And you can see all these numbers are my distinct. Once they are distinct, it means the matrix is diagonalizable. So how many Jordan blocks? Once the matrix is diagonalizable, the Jordan blocks are the size of this matrix. So Jordan blocks are my 4, 2 is the wrong. The span of the F1 and F2 is the Jordan block. Jordan blocks are my matrix. Fine, you can define the Jordan block is iota, minus iota, 2 iota, minus 2 iota. Rest all the values are 0. This is my matrix, but the span is my space, is a vector space. Space is not equal to the matrix. The right answer is only D is my correct. Let capital T is the linear transformation of the R cube. Fx is the characteristic polynomial. Suppose T is my non-zero and 0 is the eigenvalue. If I write Fx is my x into g of x, then g of t is also 0. What is that? F of t is t into g of t. Fine. So now Fx is my characteristics polynomial. 0 is one of the eigenvalue. That means the characteristics polynomial of the f is f of t 0. That means f of lambda is 0. Lambda is the eigenvalue. So I can say f of lambda is lambda times g of lambda, because f of lambda is by 0. That means g into this is 0. Either this is 0 or this 0. But since 0 is one of the eigenvalue, this may not be 0. Fine. This not always 0. You can define any of the matrix, say x square plus 1. Then clearly say 0 is the eigenvalue, it is my non-zero. You can define the x square minus 1. You can define the x minus 1. So it is not always 0. But he said gt is 0 is the wrong statement. A option cancel, C option cancel. Now look at the second option. Suppose 0 is the eigenvalue with at least two linearly independent eigenvectors. Linearly independent geometric multiplicity of the 0 is at least 2, but it's a 3. So that means geometric multiplicity of the 0 is either the 2 or 3. Then fx is again defined the similar manner, then the gt will be 0. Okay, if geometric multiplicity of 0 is 2, what will be the algebraic multiplicity? Algebraic multiplicity is either the 2 or 3. Fine, there are the two cases. But if the geometric multiplicity of the 0 is 3, then algebraic multiplicity of the 0 is also my 3, because algebraic multiplicity can't be greater than of the can't be less than of the geometric multiplicity. Once arithmetic algebraic multiplicity and geometric multiplicity are same, what does it means? The matrix is diagonalizable. Fine. That means T is my diagonalizable. 0 is the algebraic. That means T cube is my 0. Fine. Geometric multiplicity of the 0 is 3. That means T cube is 0. T is my diagonalizable. What does it mean? The minimal polynomial is my T. Fine, because it's a diagonalizable. So the minimal polynomial always linear factor. Now, what is the fx? This is my fx. Fx is x cube. I can return this is x into x square. Then what is my g of x? It is x square. Fine. Then what is my g of t? T square. Once t is my 0, t square is also 0. So for this case, this second option is correct. But now look at these other two cases also. Now, if geometric multiplicity is 2, algebraic multiplicity 2, that means t is my diagonalizable. Fine. That means t square is my geometric multiplicity, and because it's a degree 3, one's factor is another one. Say lambda x, this one. Fine. This is my characteristics polynomial. But because of the diagonalizable, what is the minimal polynomial? Minimal polynomial will be the linear factor. This is my minimal polynomial. Now, if you compare this fx is my characteristics polynomial, that is this one. What is my g of x? If you compare, this is the x square into x minus. So that will be my x into x minus lambda. Then what will be my g of t? T into t minus lambda. It is a minimal polynomial, so this value must be 0. So this is also satisfied. So this case also satisfied. Look at this case. When algebraic multiplicity of 0 is my 3, geometric multiplicity of the 0 is my 2. Then what can you say about its g of t? Geometric multiplicity is my 2. So that means x square is factor. Fine. Then then geometric multiplicity is algebraic multiplicity is my 3. How you can define that? It will be algebraic multiplicity 3, geometric multiplicity 2. So firstly I can define the characteristics. Fx will be my x cube. Fine. Now this is my not diagonalizable. So the minimal polynomial is not linear and geometric multiplicity is 2. So minimal polynomial is my x square. Now based on this x cube, you can find gx, compare them. Gx will be my x square, but x square is my minimal polynomial, so this will be must be 0. So this part is also correct. From this case also correct. This case also correct. Yes, in all the cases, B is my correct answer. So this is cancelled. B is my correct answer of this. Wi are my three distinct subspace of the R10 such that dimension of Wi is my 9. Then W is the okay. Wi's are my subspace. Fine. Capital W may not be the subspace of this. We all know intersection of the subspace is the subspace. Fine. So Wi's are the subspace of the R is power 10. So intersection is also the subspace of R is power 10. Now, how you can find the dimension of this intersection? What is given to you? Wi's are my distinct. Fine. So once they are my distinct, what does it means? If they are intersections, W1, W2, W3, then how many linearly independent constraints involved in that? At least three. Fine. At least three constraints will be there. That means the dimension of this W will be three of this constant. So at least three. So therefore, dimension of this W, what is the space is 10 minus number of the linearly independent constant. That's a 7. So 7 is less than 3, wrong. Equality is satisfied. 7 satisfied. Always remember, as I told you in my dimension of the vector space, dimension you can find as dimension of the vector space minus number of the linearly independent conditions. X and Y are my Li. Fine. Deltas i's are defined to be this. V is a span of x comma y. Then V will be 0, 0 and 0. V is the span of x and y. What does it means? That means V, what is the element of the V is U, V, W. Element of the X is X1, X2, X3, Y1, Y2, Y3. Fine. Now that's over. You can expand them. X2, Y3, Y2, X3, X2, Y3, delta 1 minus of V. X1, Y3, Y1, X3, X1, Y3 minus of this plus W. X1, Y2 minus, which is the answer of this, U delta 1, V delta 2 plus satisfied. This is a minus, wrong. This fine, but we need a positive, but we need a negative, but it's a positive. All are positive, cancel out. A is my right. US is the part of U1, U2 up to UK is a non-zero vectors of the Rn. Firstly, I can choose n is by 2. Consider the two statements given below. S is my Li, S is my Li in Rk when k is less than of the 2. I can firstly choose k is same 2. Fine. That is for this case. If k is equal to 2, that means S is my U1, U2. S is Li in Rn. S is Li. So I can choose 1, 0. This is 0, 1. Fine. So these are my Li. That means S is my Li satisfied. Then K is less than of the N. But we all have. So K and N both are same, but he said K is less than of the N. So this is cancelled. S is the linearly dependent. So can you make them as a linear dependent set? So how you can make them? I can take 1, 0 and 2, 0. Fine, they are my linearly dependent. Then UK, K is my 2. U2 I can written as a linear combination of U1. So this is correct statement according to this example. Fine. Let me extend them because they are same. I can choose n is my 3. I can choose n is my 3. That is my r cube. K is my 2. Then U1, U2 and K3. So U1 I can choose on this number 2, 0, 0 and any number say 0, 0, 1. Fine. Then clearly say they are my LD. This condition satisfied. Then UK means U3. This number U3. Can you write U3 as the linear combination of this number? No. Why? Because you can see the last two elements are my 0, but we need a 1. So this can never be written there. So that option is also cancelled. Both these statements are my false statement is the correct answer. You always choose and start from the smallest number. Any option discard, fine. Otherwise, choose for the higher number. Okay, W1 and W2 are the two subspaces. What is the intersection of this? I think that's a very simple. What is the intersection of this part? A and 2A, but it is not same. The both values are same. So this is my intersection. Then intersection is 0, 0. That's wrong because B can be any real number. If I choose B is equal to 3, then it is 0, 3 minus 3 this. This is the proper subset of this. Yes, B. If I take B as a 0, then it's one of the value. W1 plus W2 is M2. Both are same. Okay, I can find the dimension of W1 plus W2. If I prove that dimension of the W1 plus W2 is same as of the M2. M2 is my 4. Now you can find this dimension of W1. How many unknown vectors? 2. What is the dimension of W2? Again 2. What is the intersection dimension? 1. So W1 plus W2 minus intersection is the 4. Not possible. Third option, cancel out because they are not same. So dimensions are not same. So it means W1 plus W2 is not equal to M2. So once 3 is less than of the 4, that is the proper subspace is the correct answer. A is my 4 cross 4. Suppose the nullity of this. You have the 4 elements. Clearly say from this case, Z is equal to W. Fine. Or you can say you have the 4 values. I can return Z in terms of X and Y. Fine. W again in terms of the X and Y. How many independent variables? 2. Fine. So that means dimension of the nullity. That means nullity of the matrix is my 2. Once the nullity is my 2, can you find the rank? Number of the column vectors? Minus 2 is 2. So rank is 2, 1 cancel. Rank is same as of the column dimension, cancel. Rank is my 2, yes, correct option. S is the basis of the nullity. Nullity is my here. Check whether this satisfied. 1 plus 1 plus 1 is 0, not satisfied. Right option is B is the correct answer. Look at this another one. A is the 4 cross 4 dimension of this. What does it mean? Geometric multiplicity of the eigenvalue 2 is my 2. Geometric multiplicity of the eigenvalue 4 is my 1. You have the 4 cross 4 matrix. Geometric multiplicity of the 2 is this 4. What is the last eigenvalue? Rank of the eigenvalue 3, which is less than of the number of the column vector. What does it mean? Determinant of A is 0. That means 0 is one eigenvalue. Fine. 0, 2, 4 are the eigenvalue. Determinant 0. A is not diagonal. Trace is 8. How you can check about the, if I prove that algebraic multiplicity of the 2 and geometric multiplicity same, but the matrix is not given. If I prove that sum of the geometric multiplicity of the eigenvalues is the n number of the column vectors. So what is the geometric multiplicity of the 0? That's the only target we need. Now rank of the A is my 3. That means nullity of the A is my 1. Nullity of the A means I can return this time like this one. So that means geometric multiplicity of the 0 is my 1. Now geometric multiplicity is 2, 1, 1. which is 4, which is same as the number of the column vectors. Yes, this is diagonal, but he said not diagonal. This option is cancelled. A, B, and D are the right answers. Okay, W1 and W2 intersections you need to find. The first equation is this, second equation is this, and the last equation is my this number. Okay, you have to find the dimensions. You can write these pairs. Now clearly say x you can return in terms of v. From this x you can return in terms of v5, v you can return in terms of u and w. Again this v you can return in terms of u and w. Fine. So how many variables you have free? W, W, W. Oh, sorry, U, U, and U, and W, W, and W. So you have the two free variables. That means dimension of W1 is my 2. Fine. First option, yes. Now similarly for the W2, clearly say from this case, what does it mean? If I subtract them, 3x is equal to 0. That means x is my 0. If x is 0, v is my 0. Then you have this 4 variable. This value is my 0. This value is my 0. U from the first case you can return in terms of the w because x is my 0. How many free variable you have? Only one variable. So dimension of the w2 is my 1. This option is also cancelled. Now, is there any intersection? Is there any free variable common? You can see W is common in both the cases. So that means W1 intersection W2 dimension is my 1. Then what is the plus sign? What is the dimension of this one is? Dimension of the W1, dimension of W2 minus dimension of intersection. So which is not equal to 3. So the correct option is only C is the right answer. A real value function is defined as this. B is function is given to B. B of V0 comma V is my 0. Then what is the value of the W? Firstly, you can simplify this. I can choose V0. V0 is my 1 comma 0. Fine. I can substitute this value. That is, this number is my 1. This number is my 0. So x2 is my 0. X2 is my 0. This is my 1. So this is my y1. This number is my y2. So that means W is means collection of all those V's. V's is basically a y1 comma y2 such that y1 minus y2 is 0. Then not a subspace. Wrong, because it passes through the origin. Is equal to 0 comma 0. That's wrong. It is basically a y1 comma y1 in this line. Y-axis long line passing through 0, 0 and 1, 1 is the right answer. V is the vector space, W the subspace of sign and then dimension of this. If I check about the Li, cos x, alpha 3, if it is Li, then dimension will be 3. So it is for all. I can choose x is 0, sin 0, 0, alpha 2, tan 0, 0, alpha is there. If I choose x is alpha is 0. So now I can choose pi by 2, but that's infinity. I can choose any other number, say pi by 4. Then it is alpha 1 by root 2. Alpha 2 is already 0. This is alpha 3. Then I can choose as any other number. Which number you can choose so that you can find the value of alpha is 0, say pi by 6 is a 60 degree. Root 3 over 2 alpha 1 and root 3 of alpha 3. Clearly say from these two equations 0. So that means this set is my Li. Once it is Li, what is the dimension of this? 3 is the right answer of this problem. Okay, M4 is the 4 cross 4 such that I plus j is my 0. A11, k is equal to 2. I plus k is equal to 2. That is only A11. This value is 0. 3, 1 comma 1, 1 comma 2 and 2 comma 1. So the sum of them will be 0. If I call this number is b, this is my minus b. Fine. Sum will be 4. That means 1 3, 2 2 and 3 1. So if I call this number is my c, this number is my d, this number I can easily find as c minus d. This number is a1 4, that is a 5. If it is 5, 1 4, 2 3, 3 2, 4 1. If I call this d, this is my 2 3, this is my f, then I can find this number easily. Similarly for this case, if I code as a h, that is my 2 4 6, 3 comma 3, and then I can found it easily. Similarly for this case, I can found either of these two, j, this number I can found it easily, and this is my k. So how many variables are there? 3. This number is 8. This is 4. This number is 0. Because it's a 8, then the sum will be 0. How many unknown numbers? 9. So the dimension is 9 is the right answer. Okay, look at this another one. A and B are the any matrix, then dimension are same is invertible. If I choose A and B, both are my 0. Clearly say both the dimensions are same, but A is invertible, wrong. A and B, wrong. A is invertible, V1 and V2. So this is 0. If A is invertible, I can multiply both sides by A inverse, which is my V2. Fine. So V1 is same as V2, so dimension is also same. A is invertible, V1 and V3. A is invertible, then I can return this number is my V, this is 0. If A is invertible, fine. So that means this has only trivial solution. That is a unique solution. But you can see I can choose any matrix B whose rank is, say this number. Clearly say the rank of B is by 1, which is less than of the size of this V3. So definitely this is not always equal to say V is equal to 0. So that means they are not equivalent. So they are not same. This option is cancelled. So C is the only right answer. Okay, which of the following coordinate pair? Very simple. First one is the 1. I can multiply this number by minus 1, this by 1, this by 3 by taking the first option. Is it this number? Minus 1 plus 1, 3 plus 4, minus 1, 3. But we need a 1. Not. Minus 1, minus 1, 3. 3 minus 1, minus 1, 1. 0, minus 1 plus 3, 2. 0, 0, 3. Satisfied. If I multiply this 1, 1 and 3, the first number is 1 not satisfied. If I multiply this by 1, this by minus 1, this by 3, first number is not satisfied. Right answer is only D. Okay. V is the vector space, collection of all those x such that Ax is equal to 0, where x is by n cross n. Dimension of the V. There's so many times I have explained the same problem. Number of the column vectors into nullity of A. What is the nullity of A? That means dimension minus rank. Rank is R. Fine. L is greater than 1. I can choose L is my 1. Which of the following is the dimension of all those polynomial of variable, 2 variable? When L is equal to 1, have degree at most 1. A function degree at most 1. So what is the polynomial of degree at most 1? Find function of the two variable. So what is the dimension of this? 3. Now when L is equal to 1, 2, L is equal to 1, L is equal to 1, 1, L is equal to 1, it's a 3. Yes, satisfied. And you can see this is a recent year paper examination. B is a 3 cross 5 matrix such that this is my 3-dimensional. So that means nullity of the B is my 3. Can you find the rank of the B? Number of the column vectors minus rank nullity, that is my 2. Which of the following statement is or are true? V is a collection of all those R raised to power 5. Again, this is a nullity. It will depend upon the nullity of the B. Because here's a rank, you have to rank nullity you have to find as the corresponding matrix B, not for the small v. What is the nullity? 3. It's a 3-dimension. Yes. Injective 1 1. What is the condition for the injective is if you prove that the rank of the B transpose is the number of the domain, then it is my 1. Now since we all know the rank of the B transpose is same as rank of the B, rank of the B is 2, which is not same as the number of this row, number of the domain. So that means it is not 1 1. Column space of the B, that means dimension of the column space is equal to the rank of the B, which is my 2 dimension. Yes, rank is my 2. Invertible, injective, that is again 1 1. So your target is to prove rank of this, which is same as rank of the B. Rank of the B is 2, but which is not equal to the dimension of this case. So it is not possible. Kindly like and comment on my videos. V is the vector space of all those polynomials of degree at most 10. What is the dimension of this is? Degree of all those polynomials 11. W1 is the subspace of polynomials which degree is at most 5. Dimension of the W1 is 6. W2 is the subspace of all those polynomials. Sum of the coefficients are my 1. So if I consider the polynomial is a0 plus a1x plus so on, condition is a0, a1, a2 is my 0. Can you find the dimension of the W2? Is W2 is a polynomial of degree 10 minus number of the condition is my 1. 11 is the dimension, that is my 10. W is the smallest subspace of the V. W is my smallest subspace. What is the smallest subspace? We all know smallest subspace is my W1 plus W2. Then the dimension of the W is dimension of W1 plus W2. How you can find the dimension of this? Dimension of W1, dimension of W2 minus dimension of intersection. So firstly you need to find the intersection. What is the intersection? That means collection of all those polynomials of degree V1 is the degree 5 of degree 5 such that sum of the coefficient will be 0. Then what will be the intersection? Dimension of the intersection is degree of polynomial 5 is 6 minus 1 condition comes to be 5. So this is my 16 minus 5 is 11. So the dimension of W is at most 10. V is equal to W. Dimension of V 11 is the dimension of the V. Both the dimensions are same. Fine. If this happens, then we have to check dimension of W1 is less than of the dimension of W2. Dimension of W1 is 6. Dimension of W2 is 6. Fine. Dimension is my 5, at most 5. So equality appears. Yes, this is the, so B, C, D are my right answer of this problem. No, W1 is a subset of this. Just wait. W1 is the subset. I can choose W1 is polynomial of all degree. Now clearly say what is the sum of the coefficient. Sum of the coefficient is not 0. So that means this is a polynomial of degree less than equal to 5 is not the part of W2. So yes, this is the wrong. So the right answers are C, B and D are my right answer of this problem. We will see the next lecture on the linear programming problem. Till then, you can like, comment and share this video. Best of luck, students. Happy learning.